All right, so our next speakers, good old friends, Tom Igoe, professor of ITP in NYU and creator of Arduino, and require no further introductions. So, too many mic. So welcome, Tom.
Thank you, sir. Thank you very much. It's wonderful to be here. I always love coming to Shenzhen because the energy for making here is so huge, and there's so many things we can do. And literally, you can make anything here, and I think that's a wonderful thing. In talking today, I want to share a couple of stories a little bit, just to give you some background. I teach at the Interactive Telecommunications program at New York University. We are a 2-year graduate program that gives students a hands-on introduction to interactive technologies. We've been around since 1979, and we take people from all different backgrounds, not just from technology. We look for people with an undergraduate degree and a good backstory. At ITP, my role is to teach physical computing, and what that means is that I teach students to create new interfaces that enable a wider range of human physical expression to be read by computers. And that's sometimes a difficult thing to do with beginners, so that's how I became involved with Arduino, which I'm one of the co-founders of. Arduino really makes it easier to teach beginners how to do electronics. Now, over the last 10 years, there have been many, many tools that have made it easier to make things. This is the Other Mill, one of my current favorites. And the maker movement is going very strong, as we saw last year here in Shenzhen, and this year 10 times larger. And many, many more adults and children are getting introduced to this idea of hands-on learning, which is a wonderful thing. But as teachers, one of the things we often face is that when you can make anything, what do you make? And what I want to share with you today are some stories of people who found answers to that that have been most inspiring to me over the last couple of years or so, and some of the ways they've found their answers. The first way is to make things that you can use yourself and to use the things you make. And this is a story of a guy named Nick Ullman and a project he made called Bricolo. Now, Nick is a musician and a composer, and he likes to use different things in his compositions. He likes to use different objects to hit on and to make sound with. But he's kind of a traditional composer. He makes songs that are well-tuned in well-tempered scales, and he doesn't just make noise. So when he makes instruments, he wants objects as instruments, not as noisemakers. So Bricolo is a system that works like this. Basically, you've got a little motor underneath there that's playing the book, and it's vibrating on the book at whatever pitch you want. Now, Nick performs with this, and he installs it in installations every so often, and he builds instruments for other people as well with it. And what he's found in having to perform with it and to build for others is that he's made the system stronger through the fact that each time it doesn't quite work out, it gets better. And every time he builds something for someone else, he learns of new features that he hadn't thought of himself, and the system becomes stronger as he goes. And anyway, the next story is one of Matthew Epler. Now, Matthew is a filmmaker and teacher of film in Brazil and later in Jordan. And while he was teaching in Jordan, he came across this warehouse of films. This is over thousands of hours of films that had been basically rotting. They were included much history of the Jordanian royalty, included some old Russian entertainment films. And this stuff was just going to die because nobody was taking care of it. Nobody had the money to restore it. Digitizing films costs a lot of money, and Matt decided later on when he came to ITP as a student that he wanted to make it more affordable, more possible to digitize some of this history. So he built a system called Kinograph. And Kinograph is a low-cost, open-source film digitization system. He built all of the equipment with his colleagues in Jordan in mind. He built it with things that they could get their hands on. When he needed to print, he used low-quality 3D printers so that anybody could make the parts. And he shared all the files online, of course. And it doesn't just capture the films, though, it also, well, I'll let him tell you.
Frames are captured one by one. Viewed in sequence, the raw image capture looks like this. After downloading the images to a computer, Kinograph software provides tools for batch rotation, cropping, and color correction. The OpenCV library is used to extract each frame by identifying the location of sprocket holes within the image. Here's a sequence of images before and after the extraction process.
Now, the point of this story is that all the tools he were using were made by others and openly shared so that he could make a system then that was made it accessible for people who didn't have access to the high-end digitization tool to preserve their own history. And I think that's a really kind of useful thing. These next couple of stories are about community. And the first one comes from another filmmaker, as it turns out, by the name of Edwin Reed Sanchez. Now, Edwin lived in Nicaragua before he came to study with us on a little place called Little Corn Island. It's a tiny island off the coast of Nicaragua. And one of the things that happens there is that his community members really couldn't afford telecommunications because, as it turns out, when telecommunications companies don't want to invest in low-density, low-income areas. So as a result, for Nicaraguans, they spend up to 25% of their income on communication. Now, Edward couldn't go for that, so he decided he needed to do something about it. He was trying to figure it out while he was at ITP, and he took a course on telecommunications from Benedetta Piantella, and he learned about an open base transceiver system from Edist Research. And he learned how telecom systems are connected to the internet, and he thought, well, geez, that all sounds pretty simple. I can open a phone company. And so he gathered a few $1,000s from friends and a few foundations, and sure enough, they set up a cell tower on the island. And the whole rig, once they got everything up and running, cost them about $20,000. And once they got it running, they entered a business plan competition from the Stern School of Business, and they won. And so they now are providing cell service to the community on the island at an affordable rate. Now, they only have one tower right now, but they're able to provide internet access, voice over IP, and communication among the people on the island, as well as local 911. And the lesson that Edwin said he really learned in all of this is that you don't have to have $1 billion to start communications. You can start building for your community and work your way up from there. They're now starting to negotiate with other telecommunications companies to provide service to the rest of the world for these people as well. But the important thing is now they can talk to each other. They can make the community work a little better. The next story is also about community. It's about an organization called Public Laboratories. And Public Labs was a group that founded out of MIT Center for Civic Media and the Louisiana Bucket Brigade. After the oil spill, the Deepwater Horizon oil spill in the Gulf of Mexico in 2010, there was a lot of oil, and fishermen didn't know what to do. They didn't know how they were going to fish because the fish were dying because of the oil. And nobody was telling them where the oil spill was going. So what Public Labs did is they put together a simple kit that allowed you to take a cheap digital camera and fly it on a weather balloon. And then they showed people how to make maps from this, to make a map of the area they wanted to fish, so that they were able to get the information themselves to continue their livelihood. They were able to get information, the fishermen were able to get information that they weren't getting from neither the government nor the oil company about how to proceed. Public Labs' work is all about empowering people to do things for themselves. And they've continued that since then. They have a DIY spectrometer that allows people to measure pollution in their own neighborhoods. But they don't just make tools. They also make instructions. And they make simple, clear instructions designed for people who may or may not want to be makers, but they just want to get things done. And that's something that we as makers really need to learn how to do, is sometimes our role is just to support others to make their worlds a better place. Public Labs has been thriving, and this is a story of them helping a neighborhood in Chicago to clear out pollution as well. And they're growing around the US, and it's very nice to see. Another twist on this idea of making for your community is to make things you care about. And this is a story about Sharon de la Cruz. Sharon is an artist and activist in the Bronx, New York, and she is the child of 2 immigrant parents. And so she's concerned particularly about the well-being of children unaccompanied who cross the U.S.-Mexico border. There are 60,000 unaccompanied minors who cross the U.S.-Mexico border every year, and they're often smuggled in. The trip is very harrowing, and they're often traumatized by the time they get to the United States. When they get there, they are represented by a volunteer lawyer who pleads their case for them in court. It's often very difficult for the lawyers to get useful information from the children because they're terrified and because there are language and literacy barriers as well. So Sharon decided that perhaps there was another way for the lawyers and their counselors to communicate with the students. She designed a system to communicate with the children through art therapy, through drawing. So the way it works is you've got a tablet here that the child simply draws stories on, and that tablet communicates back with the caseworker's tablet, so that as the caseworker is talking with the child, it can be more conversational, but they're gathering data about what they need to help the child. She's been testing it with both children and with caseworkers, and it seems to be working quite well. There are 3 main questions that they aim to get from each child, and they are: where did you live before you came here? Who did you live with? And how would you feel on returning to your own country? And with that information, a caseworker and a lawyer can help a child much more so. And as I say, they're... Whoops. Didn't mean for the audio to be up in this one. But they're getting good success, and she's working with some organizations to try and deploy this on a larger scale now. The next part has to do with challenging our assumptions. And this is the story of Zoe Logan, who is an architect and a designer. And Zoe wanted to make something that, rather than just being a luxury item, something that served a need. And so she was working with NYU's Ability Lab, and I should acknowledge Marianne Petit in the audience, who is one of the co-founders of the Ability Lab, is with us today. She wanted to make something that made it easier for people with limited manual dexterity to cook easier. And she started with something simple. It was going to be a cooking bowl that just stayed stable while somebody cooked with one hand. But then when she started to meet with various people who could actually use her tools, she found out that she was totally wrong. And they told her, look, that's not what we need. What we need is something that makes it easier for us to chop, something that makes it easier for us to sort, and so forth. So she started to rework the whole project. And there's a good quote on her blog about the whole thing. She basically says, I worked through this quite a bit, and at the end, it's been more interesting to see the possibilities that have gone along as it will be to see the final result. But until I succeed, I'll continue to fail with as much grace as possible. And I think that's an important thing. From those failures, she reached some successes finally, and she was able to design something that was both simpler for her clients to make and use, and simpler for her to build as well. And then when she finally tested it with it, it turned out this did in fact help people to cook, to chop, to prepare with limited manual dexterity. This next story is about the future, and it's also about the past. Last year here in Shenzhen, I met a remarkable group, Karkana. Some of you may remember them. They are in Nepal, and they are an education company that works with middle school children. They help middle school kids to apply hands-on skills to their everyday lives. And I went to visit them last November, and their founders originally planned to start a design and innovation company. But as they started to do so, they found there was a lack of talented people with critical thinking skills and the ability to take risks in their area. So they decided the best thing they could do instead was to start an education company to make those kind of people for the next generation. And so during Yantra, their annual festival, is when I went to visit them last year. And it was kind of amazing to watch the work they do with children, because they do simple things and they make things about the children's everyday lives. They get children to tell their stories. These are some prayer wheels the kids made that just tell about their interests or tell about what they do every day. They get the kids to articulate their lives. Now, much as amazing as that was, the work they've been doing since the recent earthquakes is just kind of astounding. They, first of all, picked up right away, and second of all, decided that they needed to really work with teachers and students to help recover quickly, that just because they were in the midst of recovering was no reason to stop learning, to stop making. And so they started to work on a series of exercises and curricula to develop mental health through introspection, through discussion, and through activities and making. Now, the schools kind of looked like this after the earthquake, so they started teaching outside. And they worked with teachers to talk about the science of the earthquakes and to really communicate with the kids about it so they understood what was going on, so they understood what was happening. They weren't just fearing everything. They also worked on exercises to help both the teachers and the kids build their feelings, to understand that by working together they could get through this. So they worked both on the scientific side and on the emotional side, which is really important, I think. And in doing these exercises, they weren't just talking. They were making, they were doing, they were using collage, they were using making as therapy. And so far, they've managed to reach about 6,400 teachers since as of June 13th, and they're continuing this work. Now, for me, Karkana's work really epitomizes the idea that making is not just an end. It is a means to communication, to discussion, to understanding. And it's something as teachers we have to recognize. This last story is about Tim Dye. And Tim is a meteorologist by training. He thinks about how air moves and what's in the air and how it affects our bodies. And he works for a company called Sonoma Tech. This is airnow.gov, which is a project they did for the United States Environmental Protection Agency that lets you just find out about the air quality in your area. It's since expanded to AirNow International, China being the first international partner on it. But Tim also likes to tinker in his garage. And one of the things he does in his garage is he picks up some of the low-cost air quality sensors. Now, the tools he works with are $50,000 to $100,000 tools, so not everybody can use them. But you can get air quality tools that are, you know, $5, $10, $15. What Tim does is he not only evaluates them for how good they are, but then he writes clear instructions for people to understand how to use them well and how to really read them to understand the air quality in your own area so that you get hands-on experience from someone who knows what they're doing behind it. Sonoma Tech is also an interesting company because they are a for-profit company, but they are mission-driven. Their goal isn't just to get larger. Their goal is to help understand and improve air quality, and they've managed to make a successful business out of it. And one of the things I really respect about them is that they've managed to show that you can make money and still hold true to your ideals. You can actually not have to focus purely on the profit. You can focus on what it is you really care about. So a couple of points I want to say in conclusion. First of all, this one here, we're not just makers. We all make things, sure, but we all have other interests. The stories I've told you today have been filmmakers, have been storytellers, have been activists, and the things we choose to make come out of those other activities and those other interests and ideals in our lives. And it's something that makes I think our work much more meaningful when we do that. And second of all, as teachers, we can't just teach how to do things. We really have to help our students answer the question why. I think a large part of our goal really should be to help our students articulate their ideals and figure out how to realize them. And with that, I'll stop and say thank you very much and hope you enjoy the rest of the Maker Faire.